Sometimes when you are solving an equation, you're actually just trying to rewrite the equation solved for a different variable than the equation is originally written. Here we have the standard equation for simple interest. You start with a certain amount of money you're going to call the principal, so we label it P, and then you earn interest on that principal with a certain rate that's a percentage written in decimal form, and for a certain amount of time, usually in years. So suppose we wanted to solve that formula for R, because we were going to then plug in various principles and time and see what interest rate we would need. So I'm trying to get R all by itself. So I'm trying to undo the arithmetic around the R. The first thing I'm going to do is get rid of adding the P, adding the principal to it. So both sides of the equation need to have P subtracted. So when I do that, I get PRT on one side and I get A minus P on the other side. I'm still trying to solve for R. R is being multiplied by P and T. So I want to undo multiplying. Undo multiplying means that I am going to divide. So I'm going to divide both sides by P times T. And when I divide this side by P times T, I will get R. And then A minus P will also have to be divided by P times T. So that's the formula solved for R. That would, be my solution. I could also be interested in solving it for P. I might want to plug in different amounts of money I'm aiming for and different amounts of time and different rates and figure out what principle I would need to start with. So what we would want to do in this case is recognize I'm trying to solve for P, so I'm trying to isolate P. So I need to have only one location for the P, so I need to factor out P from both of these terms. And notice that when I factor the P out here, that term in the parentheses turns into a 1. P times 1 will be P, and then P times RT will be the PRT that I had. So I've correctly factored out the P. I'm trying to solve for P, therefore I'm going to divide by what is multiplying the P, which is 1 plus RT is what was multiplying P. And when I do so, this side gives me P because I've divided out the 1 plus RT, and on this side I get the amount divided by 1 plus RT. So that was an example in which we took a formula and we solved for different variables than what we were originally given. You also could have another fairly famous formula, the rate equals distance over time formula. So normally you're given the formula in this form, rate equals distance over time, but you might be interested in the distance and you might want to solve for D. So to get D by itself, I need to cancel division, and so the opposite of dividing is multiplying. So I will multiply both sides by T, and there you go, rate times time equals distance. Or I might be interested in the time. I might want to know, well, how long is it going to take me to get somewhere? So my first step is actually to do the step we did up there. And so if I have R times T equals D, and I'm trying to solve for T, then I want to divide both sides by the rate. And so T equals D divided by R. I now have the rate distance time formula solved for the time. You could have all kinds of formulas. So what if we had the formula for the volume of a cone? A cone is a third of a cylinder. So picture a cylinder, a can shape, and then you've trimmed away 2/3 of it to form your cone. So the volume of a cone is 1/3 times pi times radius squared times the height of the cone. Well, I might want that solved for R, solved for the radius. So first, let's multiply both sides of the equation by 3, because doing so will cancel out the multiplying by 1/3. So 3 times the volume would equal pi times r squared times h. And then if I'm trying to get r by itself, I want to divide what is multiplying r squared. So I'm going to divide both sides by pi and h. And that leaves r squared on this side, and then 3 times the volume is being divided by pi h. And I still want r, so I'm going to undo the square by taking the square root, and now I have solved for r. Notice when I'm doing this, I don't have to worry about putting plus or minus the square root, because it's a radius, and a radius is a length, which should always be positive. If it were not positive, you would not have a cone. I could take that same formula and be interested in the height, and so start off the same way, get rid of the 1/3 multiplying pi r squared h by multiplying both sides by 3. So multiplying by 3 cancels division by 3, and then to get h by itself, divide by what's multiplying the h. So pi times r squared was multiplying h. And there you go, 3 times the volume divided by pi times r squared will give me the height. Once again, you could have, infinitely many formulas. The whole idea is just to have an open mind that you don't have to solve an equation for a number all the time. You could solve it for a variable and leave variables on the other side of the equal sign.